So in comedy, there's a rule of three. Three things. Thing, funny thing. Thing, I also dock my windows. Thing, I also am subdued in trying now to, I don't even want to use the word educate, but show you something that you might not know about following the three presentations that we had earlier. Second thing. Third thing, I am most definitely not a member of the young APLers group. So this is the title of my presentation now. John has some generic problems, sad face, what can he do about them? I suppose to be more correct, Stefan has some problems with, has some generic problems. What can John do about them? The first thing I feel I should do is explain what generics are, and this is where the educational aspect is going to fail. I feel like I'm going to explain something to the room. 50% of you could explain it better than I can, and the other 50% of you probably don't care what they are anyway. But I need to do it in order to set up the context of the thing. Essentially, I'm going to tell you about a problem that you didn't know you had, and then I'm going to fix it, and then we can move on. So I stole a slide from Stefan's presentation. He talked about this producer builder, and he highlighted this stuff between these angle brackets. And this syntax that we see a lot in C#, and it's important that I sort of stress during this presentation, because we're talking about a .NET bridge, and because a lot of the documentation about things that are in .NET assume that you're using C#, we're going to see a lot of things now that are C#, because that's what you're going to see if you Google any of this stuff. And I'm going to hopefully walk through the process of what we can do to allow you to do the things that you can do in C# from APL. But in order to get there, we're going to need to look at some C# first. So here's an example of a generic class that Stefan wanted to use. Here's another example of a generic class. I asked around amongst my colleagues at Dyalog to see if anyone else had any examples of generic things that they wanted to use. And Bjorn jumped up with an example of a Mongo database to query movies. And here, for example, there is a reference to something that looks a bit generic-y. Here is something else that looks a little bit generic-y. What we're doing here, it looks like it's a function call, and it's got some generic stuff going on because we can see those angle brackets. They're less than, greater than, and in fact there's a few of those in here. What are these generics? What are these things? And I'm not going to do anything other than point you at some links and explain the key sentences. And the important thing here is to not give away all the stuff. Right, the important thing here is this bit which is in statically typed languages. Okay, so a lot of the drive for using generic things is from statically typed languages. And C# is one of those, as is C++ and Java, as it is on this slide. And this is information I just yanked from Wikipedia. There's a similar set of statements on the Microsoft website about using .NET, using generics within .NET. But basically, the idea is that generics are types and methods for which the types of the arguments or the types of the base class, perhaps, for a class, aren't known until call time. Okay. One of the reasons why you might want to do this in the context of perhaps in generic functions is you might have a case where you want to implement a function which takes two arguments and returns a result. And you want to ensure that the two arguments are of the same type. Okay. Types are only important, remember, when we're talking really about statically typed languages. So we're talking about cases where the two arguments are each of the same type and the return of the function is of the same type. Now, with a lot of these languages, we can use overloads to do this. We could write a function that takes two ints, we could write a function that takes two doubles, we could write a function that takes two chars. But then for every type of argument we want to do this with, we need to write a new function. Okay. We might be tempted to think, certainly in C#, that we could write a function that takes an object and another object, and it returns an object. But the problem with this, from a strongly typed language perspective, is there's nothing in here that says, but the type of arg1 has to be the same as the type of arg2. And there's nothing in here that says the result is going to be the same type as any of those things. So when we come to wanting to call something like this from a typed language, it doesn't know what the types of any of the arguments of the results are, and compilers like to know that sort of thing. So this is where generics come in. When you define a generic function, and the my function is just a placeholder for all of these, you can use this syntax when you define your function in C# to say, I am a function of type T1. And then we can use the T1, and these could be any names, T1, T, anything you like, aardvark and banana, if that's what you wanted to do, although there's sort of conventions that they like you to follow, of course. But this syntax says both of the arguments need to be of type T1, and I'm going to return something of type T1. And this can be used in a number of ways. We might say I have my function 2 of type T, and it takes as its argument a vector of things of type T. This square bracket, open square, closed square, again is the C# notation to say a vector of. Okay, and then this guy will return a thing of type T. Okay, well, how it does it and what it does isn't relevant, but in terms of specifying the types of the arguments and the results, doing the generic like this means that we don't need to write the first 4 functions. We don't need to write any of these. We can just write this generic type, and the compiler will do a lot of the work for us then in terms of setting up the types and making sure that when we're called, all the types match and so on. So again, just to go through that in C#, when we want to call my function with a particular type, we concretize it, which is a great word that Stefan used earlier, and say, I want to call the version of my function that takes integer arguments, and then I can pass a couple of integers and it returns an integer result. Or I might say, I want to call the version that takes string arguments, and I can pass 2 strings and it returns a string result. And then, okay, if I say I want to call the version that takes int arguments and return an int result, then the compiler knows that I want to give int arguments, but in this case I've given a string, so it won't compile. Okay, and then this is a pattern that follows through with the other function types that I talked about before. With the generics, when we try and concretize the function call, the compiler at that point knows everything about the types we're trying to use and can complain if we get it wrong. And this is used extensively in these modern, strongly typed languages. So, all of these calls are all valid, can all be in a program at the same time, and when we compile it, the compiler's got all of the information it knows to set up all the call sites, instantiate the correct versions of the functions that we're calling, so that everything is flexible, but at the same time strongly typed. And that's essentially what generic functions are. Generic types is a very similar thing, and we saw examples of those earlier in Stefan's slide. We've got a producer builder, which is a generic type, and in the Mongo thing, we have this builders, which is a generic type. One of the .NET generic types that you will perhaps see before you see any other is the dictionary type, which is essentially a generic type, which is sort of implementing name-value pairs, except they're not names, they're keys. Okay, and the value can be typically of any single type. So if I wanted to create a dictionary which is where the keys are integers and the values are integers, I can use the C# new keyword to create a dictionary of int, or however we want to pronounce that. And then the 2 ints match the T key and T value, which correspond to the T1 that I showed before. And then when we want to add an entry to the dictionary, we have a function. Now, this isn't strictly a generic function. It's a function in a generic class, but it inherits the types from when we did the quad new on the dictionary. Okay. I'm sure any of the 3 guys that spoke would have done a much better job of it. Again, so given we've created an int dictionary, if we try and add a dictionary entry where the value is a string, the compiler's going to complain because we've said this dictionary contains values that are integers. And there may be any number of functions inside the dictionary. If we did want to create a dictionary of type string, where the values were bytes, were vectors of bytes, then we can do that here. And then the rest of the code sort of looks the same. It's just the types of the arguments and the results and so on are all different. But again, that's generics. That's generic functions where we specify at a call time what types of arguments we want to give, and generic types where when we create the instance of the thing, we specify what types we want that to act on. With strongly typed languages, APL is not one of those. So why do we care? Okay, well, there's a number of reasons why we care. These things are out there in .NET classes, in .NET assemblies. We want to use them. Stefan had an entire, completely valid usage case where he wanted to make use of things that were only available as generics. Okay. Bjorn had an example with a Mongo database where he could only access this thing through the use of generics. So they're useful. We might want to access them directly. There may be cases where we call a function, in this case set settings, which returns an instance of a generic class. Now, actually, to be fair, this one pretty much just works because it's returned to us in APL as an object, and we could just manipulate it and do whatever we like with it. But if we're obliged to maybe give one of these back to a set settings function as an argument, then we might need to create one of these. You know, and it's any .NET thing is entitled to say, you know what, I take some settings, but I'd like them as a dictionary of string, please. It's only fair that we should be able to create one of those. And at the moment, as Stefan said, that's difficult. Oh, again, he says we can't quite. We sort of can, but it's difficult. Okay, we use a thing in the interpreter a lot which is called reflection, which allows us to interrogate the properties of a .NET assembly at runtime and do things dynamically. So we could write a horrible function called NewMethod, okay, which instantiates an instance of this getCollection generic method taking of type BSON document, okay, and this is something that Bjorn wrote. So down here we call NewMethod, it does a bunch of stuff, it returns a method that we can then invoke and give arguments to. But you don't want to do this all the time. Another potential solution to this, or at least a workaround, is again a slide that Stefan showed, where he produced his wrapper class called producer, which essentially produces a generic string byte array of producer builder. And he created a new one of those from his APL code. So this is another workaround for the problem of accessing generics. Something else he could have done is we could have used another function that Bjorn sent me, generic of, which does that for you. So we can do a lot of this stuff in APL, but you have to dig deep, and it's not fun, and it's not easy, and it's not going to be fast. So we can do better. Okay, so what I'm going to do now is I'm going to jump into what can we do that's better. So, font okay? Everyone at the back good? Brilliant. So, what I've got is the need for spectacles. So I'm going to hit F12 a few times, and hopefully magic happens. So I'm going to load this thing. I'm not going to do that. We're running on .NET 6 at the moment. Everything I'm showing you at the moment has only been implemented with .NET 6 or 7 or 8. No reason why any of this couldn't be in the framework bridge. Okay. So, what I'm going to... Right, okay, so first of all, I'm going to go through Bjorn's example of the movie database. I'm not going to try and show you a new version of how Kafka works because Stefan's done that. Okay, so this is an old version of this function, which here is the line of C# that we're trying to emulate from in APL. We want to call get collection of BSON document, and we want to pass these two arguments. Now, what we can do is we can go through. Oh, hold on. Because I haven't done. Oh, I've skipped all of these. I've forgotten how to use the debugger, everybody. So we can't call it directly, we get an error. Okay, but if we call this new method thing, we can go through all of these hoops, blah, 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 blah. Then we get something that it returns a .NET thing, which tells us it's get collection, but here we can see the bit that says it's a collection of BSON document. The display form here is not the less than, greater than, but hopefully we can see all the words that we're interested in. Okay, and then we can invoke that. Okay, and this is the old way of doing it. We can do these things by hand, and it returns as a collection of movies. Okay, then we've got this next expression, which is create a filter, then run the equal function on it. So the first thing we can do is call that generic of to create this builder thing, which is a builders of type BSON document, which is sort of what the C# said, create something which is builders of type BSON document. We can do that with this APL implementation, but it's horrible. And then we can do things like, let's get the value of filter, let's create a version of the equal function taking the string as the argument. We can jump through all of those hoops again, and then we can try and invoke it, and it doesn't work. Okay, I said we can make it work. I'm sure we could make it work. At this point, I thought, you know what? I'm not going to make this work anymore. I'm going to make the new thing work. So let's come to, forget that, because that isn't going to work, but that shows you the complexity of what you could have done before and how it very quickly falls short. So broadly speaking, uninteresting, except for setting the scene for doing better. So what I've got now is a thing called synopsis new, which if I could oh, I'll tell you what, it's probably on an F12 there, isn't it? There will be prizes. I'm using the movie Runaway here as an example. There will be questions later and a pint for whoever can tell me why I've chosen that movie. I reckon probably maybe 20% of the people in the room. There's two reasons. 20% of the people in the room will know one of them. Okay, so right, so what we're doing here is we're going to create a connection to the Mongo client. Here is the line of C# that we want to call. If we just try and call db.collection straight away, that's going to generate an error. Okay, so, and then I've still got the old code in here for doing it the old way, but let's see if we can do better. Let's come to the session. We've got this database thing, and it's got stuff in it. We can auto-complete this stuff. Now, there's a number of things in here, but one of the things we can see in here is a thing called get collection. And there's get collection here, and there's a little blob by that. And that is an indication in the autocomplete that this is a generic method. Okay, so let's autocomplete with that. We hit enter on that, and it's got a display form not too dissimilar to what was going on before. It's get collection. It requires a type to tell us what type of document we want to return. Now, it was no coincidence that the autocomplete put the blob there, because this is an operator now. This is implemented as an operator in this experimental version of Dyalog APL that I've got. So now I can furthermore carry on typing here. Okay, so now I can autocomplete here with BSON document. Okay, now if I hit enter on here, what we get back now is a function, the display form of which has got all the words we're interested in, is get collection and BSON document. So I can invoke this with the two arguments. Okay. Now this is also going to error. This is errored with a domain error, because what's happened here, the rules of binding is that the operator has consumed this as an entire array. So in order to say no, those are two arguments to the one function, we can do that. And the return form of this then is, let me just, well, what I can do actually is let's take this and cut and paste it into my function. Where we can delete all of this stuff. Okay, oh, when we want to assign that to a thing called collection. Wouldn't it be good if my APL keyboard were? There we go. So now I can run that, and that is a thing that is the collection of BSON documents. So we've taken away all of that chunk of APL that we didn't have before. We've got a new operator which we can apply to that generic get collection function. Tell it we want a get collection of BSON document. We've done that, and we've called it, and we've got the collection back. So the rest of this is basically doing more of the same. We've got this builders thing, okay, which again the autocomplete tells us is a generic thing. I want a builders of BSON documents, so we're going to autocomplete that. Now this is a slightly different use of the operator, because in the first case get collection was a method. In this case builders is a type. So we're using the operator with arrays on both sides, but we can do that. What this does, if we just execute this, is it returns a .NET type of builders of BSON document. So what we can do is we can, in fact in the example we don't need to create an instance of it. All we want to do is to get the filter from that. And that's returned a filter definition builder. Okay, let's assign that to a variable. Okay. And now we want to do filter.eq. Okay, it's generic of type string. Okay. We're going to need to put parens around that, and we want to get the thing, the title of which is runaway. Okay, so we get a thing back. Okay, so all of the code in here becomes, all of this stuff, all of this disappears and basically becomes these two lines. If we don't need any of that, we'll paste that in there. We'll get rid of all of this. Don't need that anymore. So again, we've collapsed, we've spread it out a little bit. We have that one line of C#, which now becomes 2 lines of APL code, which are similar to the C#, similar enough that if we saw the C# documentation, we'd figure out what we needed to do in APL. Okay, and it does the same job. So we also don't need any of this stuff. Okay, so the next thing that we want to do in the C#, let's just run through there, is the C# tells us what we now need to do is we need to call the generic the find sync generic method of filter and call this thing called first. Now this is tricky for us for reasons that I won't go into. We need to do something slightly different. We can't call first directly is the reason why we can't do this. So we have a little bit of extra stuff at the bottom that is splitting those things up for us. So I've got a little proof sheet here to make sure that I do the right thing. So what we need to do here, rather than just calling first, oh, in fact, wait a minute, I haven't called any of this find sync stuff. So what we need to do is collection.find sync, okay, of the BSON document. Okay, and we're going to pass the filter as an argument, okay, as the C# does. Okay. Now, again, for reasons that I don't want to go into, I need to pass an extra couple of arguments here. Connection dot blah, 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 blah. Well, that's a shame. Let's pretend that that worked because time is short. Because I knew I'd get this wrong, and what I've got, fortunately, is a final version of Synopsys that does this for me. So let's just trace through this. All the other nonsense has gone. We've got this call to generic get collection. We've got this call to filter. We've got this call to find sync. Okay, we can do some stuff which replaces the dot first because we can't do that directly. We get some stuff back, we convert it to JSON, and then we can get the plot for the movie, and that comes out as the result of our stuff. So with this new operator, we've been able to not only call the generic functions, but we've been able to call, or not create instances, but access members of generic classes as well. Spot quiz, who knows why I chose the movie Runaway? Anyone else?
Tom Selleck character mentions APL.
Tom Selleck says, I took some light courses, APL, robotics, that sort of thing. That's why I picked that movie. I said there was 2 reasons. Anyone know what the other reason was? So it fit on the slide. I didn't have room for Back to the Future there, which is what Bjorn gave me at the beginning. So, So that, all of that, oh, where have we gone? Wrong machine. Right, okay, so the next thing, let's not do any of that because I'm running out of time. Just quickly with the Kafka stuff, there's a function here called Kafka, which we can use the same mechanism to produce the generic types that Stefan wanted to use. We want to produce a builder of, where I can't remember what the names of these things were, but I produce a builder of type string. Okay, there's some extra stuff going on here, which I won't go into because I'm short of time. So that's great. That's one side of the picture. Okay. Next side of the picture, of course, is that C# uses this a lot. We want to be able to consume these generic classes that C# uses. At the same time, we want to be able to produce generic classes in APL that can be consumed by C#. Here is an example of an APL class. It's a thing called ostats. Okay, it's got a number of functions in it. It's got a constructor that takes a vector of objects as its argument. So it'll take a vector of anything you want to give it. Okay, and it just remembers that array in a global variable, essentially. Then it's got a number of functions. It's got one called min that uses grade up to determine what the minimum element in this array is, the first in a sorted list. It's got a function called max that returns the first in the grade down list. It's got a unique that returns the unique of the array. It's got a function called frequency that tells me how many times each element appears in the array, and it returns that as a .NET hash table. But the problem with this implementation is the same as the problem we had before, that everything is declared as being object. So there's no guarantee that when you call min, you're going to get something back which is the same type as the object array that you passed in. If we convert this into a generic type, we can use the same blob that we used at call time. We can say, I'm going to implement this generic stats class of type T. All of our objects references become T references. When we want to return our hash table of the frequency, how many times did each thing appear, we can use the system.collections.generic type and create one of these dictionaries. We can say, my frequency is now going to be a dictionary of type 2, which was specified up here, and then of int, because we're going to assume that none of the elements of the array appear in it more than 2 to the 32 times. And I haven't got time now, unfortunately, to go through that, but here I've got a C# project that uses the object version of that thing, but this is full of casts so that the C# can convert everything back to integer in the case where we want to have pass a vector of ints. But underneath, I can say, well, let's create a gstats, that's the APL class of type int, and all of those casts and everything fall away because now the C# code has got all the strongly typed information that it needs in order to, well, first of all, there's two things going on. First of all, the interpreter knows what type of result it needs to return for everything. And the C# code here knows what type all the returns from the APL code are going to be, because that's a contract you set up with a generic. I'm a generic of int. That means I'm going to return ints for everything, or at least with this class. So the C# code gets a lot easier because we've now implemented that generic type in APL. And that works, but I haven't got time to show you that it works. I also haven't got time for any questions, which is a big shame. I've done this presentation now once. I will probably never do it again. But if I do it again, I'll do it in 45 minutes, not 30 minutes. I hope it made sense. I hope that the 50% of you that knew what generics were are happy that I did a good job of explaining that and showing them. And I hope that the 50% of you that didn't know what generics were now do know what generics are and maybe see how and where you might be able to use them when you're talking to .NET. And we might extend this when we're talking to Java, via Java bridges and other things. And there's a whole question about, do we want to have generics in just raw APL classes and raw APL functions? And that's something we can talk about a lot. But for now, it's in the .NET domain. The work is there. It's not finished, but there's enough there, I think, to show that, you know what, we can probably in version 20 have something that's going to be useful. And now I really must stop. But thank you for your time.